Hello class. In this episode, we're going to learn about the sine and cosine of complements, and also how to find the side lengths of non-right triangles. First, here's our SOHCAHTOA. Those three ratios, make sure you have this memorized. So here we have a general right triangle. That is, all you have are variables here. We don't have any actual measurements. I'd like you to fill in the table based off of the variables here, and then compare your table with my table. So first for alpha, we have adjacent over here and opposite here. So the sine of alpha is a over c, and the cosine of alpha is b over c. Now, if we are to look at beta, we would instead switch the two leg names. So beta is over here. So now the adjacent is a, and the opposite is b. The sine of beta is b over c. The cosine of beta is a over c. So now what can we say about any right triangle based off of these results? We can say that the sine of alpha is always equal to the cosine of beta. We can also say that the cosine of alpha is always equal to the sine of beta. And this is a very important relationship. If we look here, we can now say, in general, that since we know that the cosine is equal to the sine of a complement, we can write these two equations here. That is, if we add up the angles that are being used on each side of the equation, they have to add up to 90 degrees because they're complementary. So whenever you have in an equation sine equal to a cosine, just set the angles equal to, set their sum equal to 90 degrees. So that's a big idea for today. In exercise 1 here, let's go through these problems. Let's see, what's alpha plus beta? Well, we know that that's a 90-degree angle, and all of them are 180. So 180 minus 90 must be 90. So they are complements. Using our trig ratios, write BC over AB in two different ways. So here are the two ratios. You could have also had, instead of angle A, alpha, and instead of angle B, beta. That's fine. Do the same thing for AC over AB. Here you have these two ratios. So what can we say about the sine of alpha and the cosine of beta? They are equal. That's based on what we did before and on this part B. Same idea. And part E, what about cosine of alpha and sine of beta? Like part C, those must be equal. So see if you can solve each part here on your own, and then I'll show you my solution. So what's the value of theta if sine of theta equals cosine of 25? Well, we know that the angles must be complementary, so 90 minus 25 gives us 65. Similar idea here. What's the value of theta? It must be 10 degrees. Now here's one that's a little bit more complicated, but same idea. But in this case, we can't just subtract from 90. But what do we know about theta and theta plus 10 degrees? What must these two angles add up to? Think about that and solve it, and I'll show you my solution. Well, we know they're complementary, so they must add up to 90. So our answer is 40. And here's the algebra that goes along with that. And a similar idea here. What's the value of theta? You know, these two angles must add up to 90. You get 67.5 degrees. And finally, for angle measurement, are sine and cosine equal? And another way of stating that, when is this equation true? When is that equation true? Well, that's going to be true when the angle is 45 degrees. And that makes sense since it would be an isosceles right triangle. So those two ratios would have to be the same because both legs would be the same length. And here's a little bit of algebra that proves a little bit further. So here is a little experiment, a little thought experiment on what happens to sine and cosine at 0 degrees and 90 degrees. And the reason why we can't really answer that using what we have so far is because we can only talk about right triangles. And we're looking at the acute angles, not the right angle. And so since we're only looking at acute angles with trigonometry. We can't have a 0-degree angle in a triangle. And we can't have a 90-degree angle because then we'd have two 90-degree angles. So let's see what happens to these values in GeoGebra. So what happens to sine and cosine as we approach 0? So in this case, we have this quarter circle. And the hypotenuse isn't changing. It's always 1. There's my little slider that controls the angle. And what happens as this value of theta gets closer to 0 degrees? What's happening to sine and cosine? Well, sine is getting closer to 0, and cosine is getting closer to 1. And why does that happen? Well, for sine, the opposite side is getting smaller and smaller, and for cosine, the adjacent is getting larger and larger, closer to 1. So that's our answer for this first part. So for 0 degrees, sine of 0 is 0, cosine of 0 is 1. Now, what about as we go to closer to 90 degrees? What happens? And notice that when we go to 45 here, that these are both the same, square root of 2 over 2. And if we get closer to 90, sine is getting closer to 1, and cosine closer to 0. So that's what's happening here. So based off of all of this, we have, by definition, not really based off trigonometry because we can't use triangles, sine of 0 is 0, and cosine of 0 is 1. And this coincides, these results coincide with what we learned about this cosine being equal to the sine of a complement. Right? Sine of 90 is 1, and cosine of 0, which is the complement of 90, is 1 as well. And same holds for cosine of 90 and sine of 0. So here we have common angle measurements seen throughout math. And what do you notice about the table here? What do you notice about this table of values? So you really should have these memorized. And these are all based off of the two special right triangles here, what we just learned about. So sine and cosine of 0 and 90 are what we just saw. And these are all derived from the triangles here. What do you notice about the table values? Well, you just reverse the order. And that makes sense because 0 is the complement of 90, 30 is the complement of 60, 45 is the complement of itself. And so all of this all relates. The second row is related to the first one based on what we learned in this lesson. And if you're having trouble remembering what goes in the rows, just label the sides. If we're looking at 30 degrees, the sine opposite x over 2x, which is just 1/2 when you reduce it, and the same for the square root of 3 over 2. So you can fill out the rest of the table based on the triangles. And finally, here's an example with a triangle that's not a right triangle. Ioana here wants to use Pythagorean theorem to figure out how much fencing she needs. Is that a correct way to do this? Yes or no? What do you think? Well, not really. This is 95 degrees, and it's not quite 90. So we'll get an approximate answer, but it won't actually be mathematically correct because it's not truly a right triangle. So how can we actually do this precisely? Well, what would happen if we dropped an altitude from our 95-degree angle? Is that helpful? Well, if we do indeed drop an altitude, then we have a right angle here. And then we'll have two right triangles. And once we have two right triangles, then we can just use trigonometry to figure out the length of that third side, see how much fencing she needs. So the goal now is to figure out what's x plus y. So see if we can solve this problem, and then I'll show you my solution. So to find x, we're looking at the cosine of 35 degrees. To find y, we're looking at the cosine of 50 degrees. So we have adjacent over hypotenuse, adjacent over hypotenuse. And we solve each of these for the variables. And now it's just a matter of plugging these into the calculator. And we get about 130. They don't actually tell us the units here, so keep that in mind. So put this in the calculator, make sure you are in degree mode first. And let's see, x is 100 times the cosine of 35. Those where closing your parentheses are important. Right? If you don't do it, it's not going to do the correct order of operations. Plus 74.875 cosine of 50. And we get our expected answer. So she will need about 130 units of fencing. If it's meters, it'll be meters, feet, etc. All right, in this lesson, we learned how to apply the sine and cosine of complementary angles and how to find side lengths in triangles that are not right triangles. Thanks for watching this video.